Hello and welcome. This is the first video in a series about how to integrate for A-level maths. This first video is going to be focusing on just AS maths, so if you're in first year, this should be perfect for you. It's highly recommended that you have a good grasp on differentiation first, so make sure you watch the video linked up there in order to understand what's going on in this video. Let's get cracking. So if you know your differentiation rules, you will know that you can almost treat it as one of those function machines from year 8. What we have to do is we have to take the power and times by it at the front of the x term. And then once we've done that, we have to subtract 1 from the power. And that process gives us the derivative. So for example, this is the derivative of x to the power of 6. We times by the power to get 6x, take 1 away from 6 to get 5. That's the process, 2 steps, 2 simple steps. Well, integration is the complete reverse of that. So you have to treat it going backwards. What's the backwards of minusing 1 from the power? Well, it's adding 1 to the power. And then what's the opposite of timesing by the power? Well, of course, it's going to be dividing. If you know your inverse operations, I did not mean to write the word divide there, dividing by the power. And if we follow these, again, 2 simple steps, this will help us integrate anything from first year maths. Again, I'll carry on with this example over here. If we take 6x to the 5 and we integrate it, well, let's follow the formula. Let's add 1 to the power. So it's now going to be x to the power of 6. 5 add 1 is 6. And then we're going to divide by that power. The power is 6. So we do 6 divided by 6, which is just 1. So I won't bother putting that down. As I said, integration is the reverse of differentiation. So it should make sense that if we differentiate to get this answer and then integrate, we should get back to the same thing we started with. There is a little caveat, which I'll mention later on about this. For me, this wordy version is much easier to remember because I can associate it and I can picture those words in my head. For you, you might prefer a formula. So if that's the case for you, if you need to integrate ax to the n, then we'll do add 1 to the power, which is n plus 1, and then divide by the new power, n plus 1. The a simply just stays there. So if you'd like to remember it as an actual formula, you can. Although, how did I actually use the formula? How did I work it out? I used the worded version anyway. Choose what works for you. Right, now time for that sneaky caveat that I mentioned before. Something that means the formula isn't quite correct, but with a little addition it will be. Think about the derivative of x to the 6 again. So the derivative was 6x to the 5. We saw that before. What about the derivative of x to the power of 6 plus 5? The derivative is still 6x to the 5. What about the derivative of x to the power of 6 plus 1,234,567? The derivative is still 6x to the power of 5. So you'll notice what's happening. Many functions, in fact, infinitely many functions, will all differentiate into the same answer. So when we do this process of integration, when we reverse the process, how do we know whether we're going to get to this version, this version, this version, or another version that we haven't even mentioned? Well, that's where we add on this constant that we call c. You could change the letter if you want. C is the universal version of this because I guess constant begins with the letter c. What this c means is the answer could be any of these: x to the power of 6 plus nothing, x to the power of 6 plus 5, x to the power of 6 plus this number. It just doesn't matter. That c takes into all of the possibilities. So if we wanted to, as I say, integrate 6x to the 5, the answer would be x to the power of 6 plus c. You cannot find that c unless you are given more information. Don't feel like you have to find it. Some answers would literally be plus c at the end of answer, walk away, move on to the next question. So if I move back up and correct my formula then, the actual formula, integrating ax to the power of n, will still be this, with a cheeky plus c on the end. Now so far, all I've said is the word integrate. Integrate this, integrate that, but I haven't shown you the notation, so I'll do that next. If we wanted to integrate, let's say, 6x to the power of 5, what we do is we put a nice squiggly line in front of the term that we want to integrate. And then at the end, we put a dx. These two symbols together mean that we are integrating. Specifically, this dx you don't really need to understand fully, but it means with respect to x. It means what's inside the integral, as in this bracket here, what's inside the integral has an x in it. If that were a y, then things would be completely different. For AS level, just note that if it's not the same letter, you can treat it as a constant, as a number. You won't be asked to do anything too out of the ordinary with this. And a bit of history, this big symbol over here doesn't have to be that big. It looks kind of like an elongated S, and in fact, it's supposed to mean sum. So we won't do it in this video, but we'll look at it in a future one. It's the summation of little tiny rectangles that we're technically doing here, and that's why the S, the integral sign, looks like an S. And then when we give our answer, we can say equals. In this case, if we follow that formula from above, let's add 1 to the power and divide by the 6. We get x to the power of 6. We already know that. We've seen it multiple times already. And then with our plus c at the end, like this. And again, if you're a formulaic person, if you want that formula, it would be the integral of ax to the power of n. That a could be any constant. Can you see that a just remains the same? You don't have to integrate the a because this only says with respect to x. And then this formula will be the same as before, again with the plus c. So I'll put that formula in a box if that's useful to you. Make sure to get that down so you can use it for the further examples that we're going to do. Shall we look at some examples then? In example 1, we've been asked to integrate 15x to the power of 4 with respect to x. As I say, it's pretty much all going to be with respect to x in this video. So what we're going to do, we're going to follow that formula. So if you've got that formula written down, either in the words or in the actual letters, let's follow it along. Let's add 1 to the power. So 4 plus 1 is 5. And then we're going to divide by the power, divide by 5. And then the 15 is going to remain where it is with our plus c at the end. Of course, this can be simplified a tiny bit. If you see a simplification like this, so 15 divided by 5 being 3, go for it and simplify it. I know it's another line of working, but you may lose out on a mark if you miss it out. So our final answer would be 3x to the power of 5 plus c. Now example 2 has some harder integration, and also it's got two terms. So firstly, if it's got two terms, simply do one at a time. That should make sense if you've done the differentiation, because if you have to differentiate two things, then you just do the first thing and then the second thing. So if we can integrate 12x and then we can separately integrate 12, we're good. Why is this integration harder? It's simply because there's no power of x that I see, neither on the x here nor the x here. That means you have to come up with it yourself. What is that power? Well, it's technically 1, isn't it? What's the power over here? What's the power of x? That's right, it's x to the power of 0. Remember, x to the power of 0 is equal to 1, which means 12 times 1 is 12. So this now has a power of x. The formula can now be applied. However, it's obviously not written like that. We don't go around writing 12x 0 o'clock when it's 12 o'clock. Now we've got it in this form, we follow the formula. Let's see, let's add 1 to the power to get x to the power of 2. And let's divide by the power of 2 with the 12 staying in place. Let's add 1 to the power to get x to the power of 1. Divide by the 1 and leave the 12 in place. With the plus c on the end, we don't want to forget that. Now it's just time to simplify, so 12 divided by 2 being 6, and 12 divided by 1 being 12. X to the power of 1 is simply x. We've seen that already, so 12x, and then the plus c at the end. So here our final answer is 6x squared plus 12x plus c. Okay, over to you. Exercise A, I would like you to integrate 1 plus 2x cubed plus 4x to the power of 5. If you struggle, let me know in the comments and I'll be sure to help you out. And I'll give the answer in 5, 4, 3, 2, 1. The answer will be x plus 1/2 x to the power of 4 plus 2/3 x to the power of 6 plus c. Hopefully you got that right. For now, we've been integrating x to the power of positive integers. But what if you wanted to integrate, say, the square root of x? Well, lucky for us, if we know the rules of indices, we know the laws of indices, we can convert this into x to the power of 1/2 like this. If that is not familiar to you, make sure you review your laws of indices. Once it's x to the power of 1/2, you may be thinking, do we need another rule, a separate rule, a more complicated rule because it's 1/2? Well, no, you don't. It is the same rule. It's great. We're going to add 1 to that power to make it 3/2. So add 1 to 1/2, it's 1.5, 3/2. And then we're going to divide by that power. So divide by 3/2, like this. Of course, that doesn't look great. So once I've added on my plus c, I'll just quickly rearrange that. The 2, because it's the denominator of the extra fraction, will pop up to the top. So 2/3 x to the power of 2/3 plus c. It's exactly the same rule, but you've just got to know how to convert it into something where the rule can be applied. Because of course, you look at this, there's no power there at the moment. So as long as you know how to convert it, you can use the formula all you like. How about example 4 then? The integral of 1/3x squared dx. What's the rule here? How are we going to convert that into x to a power so we can follow the formula? At the moment, it's in the denominator, and that's definitely not what our formula says. So what are we going to do? Well, do you notice that if we write this as 1/3 times 1/x squared, then we can write this as 1/3x to the power of -2. Do you remember that minus means it's the reciprocal, it's 1/. And I don't know about you, but when I look at that, I'm thinking that we can use our formula. Let's add 1 to the power. Be careful with the negative powers. When we add 1, -2 add 1 is -1. You might be inclined to put -3 if you aren't fully focused on the question. And then let's divide by the -1. And then the third stays in place. Again, it doesn't look too nice like that. Take the denominator of the extra fraction and then send it to the other side. So send it to the denominator in this case. I'll probably do one more step just because it's a bit more aesthetically pleasing. I'm going to put the minus on the numerator rather than the denominator. Add the plus c, and then we're done. I've got 2 more examples for you, example B and example C. Try these now, and I'll give both answers in 5 seconds. So when simplified, the answer to the first one will be 3/4 x to the 4/3 minus 1/2 x to the -2 plus c. And the second one will be 4x to the power of 1/2 minus 1/10 x to the -4 plus c. You may have written those in many different forms. For example, this one could have been written with a square root. This one could have been written as something over x to the 4. If it's equivalent, then it's fine. You'll still get all the marks, don't worry. We've got 2 further examples now to show you what might happen if it's not given in the correct form. You're going to have to do some rearranging and manipulating to turn it into the right form. So for this first one, x plus 1 squared, sure there's the power of 2, but it's not x to a power, so we're going to have to change something here. How are we going to integrate it? The only thing we can do is expand. So if we expand, we're going to get the integral of x squared plus 2x plus 1. All 3 of these terms are now something that we can integrate. So we integrate one at a time. We're going to get x to the power of 3 over 3. We're going to get x squared. The 2 cancels out with the 2. plus x, and then plus c. So if you ever have something that's not in the right form, expand it out, get it into the right form, and then you can integrate like we've done as usual. Once you get to second year maths, there is another way to integrate this, but that is definitely a story for another day. For the second one, it's got a big fraction in there. So I'm definitely thinking it doesn't look like the rule that we know. So how are we going to remedy this? Well, let's separate the fraction out into x cubed over x, which by the laws of powers will be x squared, and then x squared over x, which by the laws of powers will be x. Now, everything's looking quite nice. We can integrate x squared, we can integrate x. So in this case, we're going to get almost the same answer as before. We're going to get 1/3 x cubed, and then we're going to get, in this case, 1/2 x squared plus c. Two more exercises for you then, E and F. The second one uses the laws of indices quite a lot, so make sure you understand how to get to the answer. As usual, I'll give you 5 seconds and then I'll reveal the answers, but make sure to try them yourself. The first one will be x to the 4/4 plus 2/3 x cubed plus x to the 2/2 plus c. And the answer to exercise F will be 2/3 x to the power of 3/2 plus 2x plus 2x to the power of 1/2 plus c. If you're feeling up for it and you really want to test what you've seen today, try this bonus integral. It's got every single thing we've seen and it puts it all together in one whole integral. Okay, that concludes today's video introduction to integration. All the integrals we've seen today are what we call indefinite. Next time we're going to see some limits, which means they'll have numbers on the integral like this, and they're called definite integrals, but you have to catch me in the next one to see what they're all about. Well, there you have it. Now you know how to integrate any AS function. Make sure to watch the next video in the series to understand limits with integration and areas under curves.